welcome to my channel Civil Lab. In this video, I will be discussing strength of materials subject from Khurmi and Gupta book from question number 31 to question number 60. So let's start. Question number 31. Modular ratio of two material is the ratio of. So option C is the correct answer. Modular ratio is the ratio of modulus of elasticity of two materials. So option C is the correct answer. Question number 32. The shear modulus of most materials with respect to the modulus of elasticity is. Friends, keep in mind the shear modulus of most materials with respect to the modulus of elasticity is less than half. You know the relation E equal to 2G into 1 plus mu. E is the Young modulus of the material, G is the shear modulus of the material, and mu is the Poisson ratio of the material. Shear modulus G equal to E divided by 2 into 1 plus mu. In this relation, you can find the value of shear modulus G is less than half of the Young modulus of the material. Next question is question number 33. A rod is enclosed centrally in a tube and the assembly is tightened by rigid washer. If the assembly is subjected to a compressive load, then friends, look at the scenario. The diagram. This is the rod enclosed centrally in a tube. This is tube, and this composite section is subjected to a compressive load. So both the tube and rod will be under compression. So option number C is correct. Both rod and tube are under compression. Next question 34. A bolt is made to pass through a tube and both of them are tightly fitted with the help of washers and nuts. If the nut is tightened, then again look at the diagram. This is tube, this is nut, and this is nut, and this is bolt. This bolt is passing through here to here, and this is tube, this is a washer, and the bolt is tightened by the washer and nut. So friends, as the nut is exerting compressive force to washer, then ultimately it will compress the tube, and if something is compressed, we know it will exert stress resisting force. Here the resisting force against the compression is tensile stress. So tensile stress will act against the bolt, so it will feel tension. So friends, the tube will be under compression. Option number D is the correct answer. Next question is question number 35. When a bar is subjected to a change of temperature and its deformation is prevented, the stress induced in the bar is, let me tell you, when a bar is subjected to a change of temperature and its deformation is prevented, then the stress induced in the bar will be called as thermal stress. Option D is correct answer. Thermal stress, option D. Next question 36. A steel bar of 5 mm is heated from 15 degrees Celsius to 40 degrees Celsius and it is free to expand. The bar will induce no stress because it is free to expand, so there will be no stress in the bar. So option A is correct answer. Next question, question number 37. When a bar is cooled to a minus 5 degrees Celsius, it will develop. When the bar is subjected to a fall of temperature minus, so it will develop tensile stress. So option C is correct. Question number 38. A bar of copper and steel form a composite system which is heated to a temperature. The stress induced in the copper bar will be compressive. Friends, keep in mind, in a composite body system, the material having greater coefficient of linear expansion with the rise of temperature will always be compressive. So option number B is correct, compressive. So question number 39. The thermal stress in a bar is directly proportional to the change in temperature. Option A is correct, because we know the relation thermal stress equal to alpha T into E, where alpha is the linear expansion of the material, T is the change in temperature of the material, and E is the Young modulus of the corresponding material. Next question, question number 40. The thermal stress, option B is correct answer, does not depend upon the cross section of the bar, because you know the formula, thermal stress equal to alpha into T into E. Here thermal stress does not depend on the cross section area of the body, so option number B is correct answer. Thermal stress does not depend upon the cross sectional area of the bar. Point question number 41. If there is a fall in the temperature of a composite body, then a member having having greater coefficient of linear expansion will be subjected to compressive stress. So friends, here the temperature is falling, so the member having greater coefficient of linear expansion will be subjected to tensile stress. So right answer is the B, false. Next question is 42. The thermal or temperature stress is a function of, we know the formula of thermal stress equal to alpha TE. So alpha is the linear expansion of the material, T is the change in temperature, and E is the Young modulus of the material. So friends, thermal stress is a function of all of this. Option D is the correct answer. 43. When a circular bar tapering uniformly from the diameter d1 at one end and diameter d2 at the other end is subjected to an increase in temperature, then thermal stress induced is, question number 43. If a bar is like this, and tapering diameter d1 and d2, thermal stress will be equal to alpha into T into E into d1 total divided by d2. You know the notation, alpha is the linear expansion of the material, linear expansion of the material, alpha is the coefficient of linear expansion of the material, T is the change in temperature, E is the Young modulus of the material, and d and d2 will be the corresponding tapering diameter of the material. Next question, question number 44. Which of the following is correct? Option number D is correct answer. Stress is directly proportional to the strain within elastic limits. We know that from Hooke's law. Next question 45. The deformation of the bar per unit length in the direction of force is known as linear strain. So friends, keep in mind the deformation. Suppose this is a body, and this is a body, this is a linear direction, and this is transverse direction. So friend, whenever deformation or change in length takes place along this direction, it will be called as linear strain, and when along this the strain will be along this direction, it will be transverse strain. For question number 45, option A will be correct. Strain. Question number 46. Every direct stress is always accompanied by a strain in its own direction, and an opposite an opposite kind of strain in every direction at right angle so to it. Such strain is known as lateral strain. Option B is correct, because the opposite, this is linear strain, and opposite kind of strain is this along this axis, transverse axis, so it will be called as transverse strain. Option number B is correct, lateral strain. Question number 47. The ratio of lateral strain to linear strain is called Poisson ratio. Keep in mind the ratio of lateral strain to linear strain will be called as Poisson ratio. Option D is the correct answer. Question number 48. The Poisson ratio is the ratio of linear strain to volumetric strain. No, we know the Poisson ratio is the ratio of lateral strain to linear strain. So our option B is correct, false. Next question 49. A steel bar of 2 meter long, 20 meter width, and 10 meter thick is subjected to a pull of 2 kilonewton. If the same is subjected to a push of 2 kilonewton, the Poisson ratio of the bar in tensile will be equal to or less than or greater than the Poisson ratio for the bar in the compression. So friends, let me tell you, the value of Poisson ratio does not change with the nature of the force. So value of the Poisson ratio will be same in compression and as well as in tension. So friend, option A is correct answer, equal to. Next question is 50. The Poisson ratio for steel varies from, keep in mind option number is correct, 0.23 to 0.27. Next question 51. The Poisson ratio for cast iron varies from 0.25 to 0.33. Option B is correct answer. Next question 52. When a bar of length L with B and thickness T is subjected to a pull of P, then it's option number C is correct answer. Length increases but width and thickness decreases. Suppose this is a body. Friends, look at the body. If the body is subjected to a pull and this is the length of the body, so definitely it will increase the length. So length will be increased del plus L, but its transverse direction length will be decreasing, which will be B minus del B, and thickness also will be decreasing. Option C is correct. Length increases, width and thickness decreases. Next question is 53. The ratio of change in volume to original volume is called volumetric strain. Option C is correct answer. Next question 54. When a bar of length L with B and thickness T is subjected to a push of P, its option D is correct answer. Length decreases, width and thickness decreases. It's the same question but opposite in nature. Of the question 52. The body is subjected to a push. This is pull and the body is subjected to a push P. So in case of push, the length will decrease, but this transverse direction length will increase. Option D is correct answer. Length decreases but width and thickness increases. Next question 55. The volumetric strain is the ratio of option D is correct answer. Change in volume to the original volume. Next question 56. When a rectangular bar of length L, breadth B and thickness T is subjected to an axial pull of P, then linear strain is given by if a body is subjected to a pull of P, where T is the thickness of the body and B is the width of the body or breadth of the body, and L is the length of the body, then from Hooke's law we know stress equal to strain into Young modulus. So we also know that direct stress sigma equal to force by area. So force will be pull P divided by area will be cross sectional area B into T. So sigma equal to P by B into T. So we get the value of direct stress sigma. So if we put this value into this, then strain will be equal to P by BTE. For question number 56, question option A is correct answer. Epsilon strain equal to linear strain equal to P by BTE. Next question 57. When a rectangular bar of length L, breadth B and thickness T is subjected to an axial pull of P, the volumetric strain, same body for this body, the volumetric strain will be 1 minus 2 mu into sigma x plus sigma y plus sigma z divided by E. E is the Young modulus of the material, sigma is the corresponding stress in the direction, corresponding direction, and mu is the Poisson ratio of the material or a body. For question number 57, option number C is correct answer. Epsilon normal strain into 1 minus 2 by m. Mu is the 1 by m. Question 58. When a body is subjected to 3 mutually perpendicular stresses of equal intensity, then the ratio of direct stress to corresponding volumetric strain is known as bulk modulus. Keep in mind the ratio of direct stress to the corresponding volumetric strain is known as bulk modulus. Option C is correct answer. Next question 59. The relation between Young modulus E and bulk modulus K is given by K equal to will be K equal to ME divided by 3 into M minus 2. 1 by M is the Poisson ratio of the material, E is the Young modulus of the material, K is the bulk modulus of the material. There is also a relation E equal to 3K into 1 minus 2 mu. Next question number 60. The ratio of bulk modulus to Young modulus for a Poisson ratio of 0.25 will be, we know the formula, E equal to 3K into 1 minus 2 mu. So friends, if we put the value of mu 0.25, so we will get E by K equal to 3 into within bracket 1 minus 2 into mu or 0.25. So we will get E by K equal to 3 by 2. So option number. So for this question friends, the ratio of bulk modulus to Young modulus for the Poisson ratio of 0.25 will be 3 by 2, or option number D will be correct. So friends, see you in the next video. I'll be back in quick time. Like, comment, and subscribe.